Alrighty guys, today is a very special video. Today I will be going through the mind map I made for organic chemistry. Now, this took me a very long time to do. A lot of hard work, so I'd really appreciate liking and subscribing the video, and that would really help. But anyway, let's get into it. Alright, so it starts from the middle. This is the centerpiece. Carbon compounds. First of all, alkanes. Now keep in mind, I've made these mind maps in a way that's very easy to remember. A lot of mental techniques to help retain information and visualize it in a way that you can activate that part of your knowledge and apply it. So anyway, here we have alkanes. Now how I remember it is candy cane. So I have a candy cane, right? Cane. Think of this as cane. What I have here is a scale. Now, on this scale, this might look a bit funny, but this image is all you need to remember to understand, to truly understand the concept of alkanes. What we have here is a scale. This is a scale, right? And we have cane here, so alkanes. So from here, the scale is balanced, right? What we can infer from that, balanced, equilibrium, saturated. Alkanes are saturated. Or in other words, at equilibrium. That's the first part. So you need to know that alkanes are saturated or at equilibrium. Next, what do we see up here? A diamond on fire. Now to me, what do I think of? Diamond, carbon, fire. Think of fuel. You think of hydrocarbons. Hydrocarbons. So, we know that alkanes, from this image, they're saturated or at equilibrium. They are hydrocarbons. And finally, what else can you see in this image? This green thing here is a bond. And what type of bond is this? It's a single bond. That's what we see. Single bonds only. That's what alkanes are. They are carbon compounds, hydrocarbons, that are saturated with only single bonds. Now, from this image, what have we done? We've just deciphered exactly what alkanes are in a way that's easy to understand. And this image is pretty bizarre, don't you think? So, it's easy to remember. Okay, so we have here, saturated at equilibrium. That's the explanation. And from here is the formula for alkanes. CnH2n plus 2. Now, what does this mean? Say we have 2 carbons, right? So that would be C2. N is 2, right? So that means H4 plus 2, H6. C2H6. That's actually ethane. Okay? So alkanes always follow this pattern. CnH2n plus 2. Now, this actually details it a bit more. These are all the prefixes you need to know. Methane, ethane, propane, butane, pentane. So these endings signify that it's an alkane. But the prefix signifies how many carbons there are. Meth for 1, eth for 2, prop for 3, but for 4, pen for 5. Then hex 6, hept 7, oct 8, non 9, and dec 10. Now here, they all follow the formula. 6 times 2 is 12, plus 2 is 14. 7, and then 7 times 2 plus 2, 14 plus 2, 16. So they all follow this right here. Now, this is a Lewis diagram for it. And C2H6 can be broken up into 2 methanes. So we have methane here. Remember, carbon always has to have 4 bonds, okay? 4 bonds. That's a really important thing. Carbon can form 4 bonds because of its sp3 hybridized orbital, but that's for another video. But yeah, so this would be the Lewis diagram of ethane. So anyway, that is alkanes.